Hi students, welcome back to that is your channel Physics by Imagination. Dear students, in alternating current part 1 video, we understood what happens when current passes through resistor, inductor and capacitor. So today we are going to understand that is AC voltage through LCR circuit. Dear students, now simultaneously I am going to pass AC current with the help of AC source into the LCR circuit. Then what happens here, as I told you, reactance means the opposition offered by the material when it is passing to the either that is a inductor or capacitor. Now here when I passes through this system, then we'll call that impedance. The opposition offered by the three devices, that is called impedance. It is directly given by equation, that is Z is equal to square root of R square plus XL minus XC whole square. Very important during solving the CT problems. So now here XL means what? That is inductive reactance, that is equal to 2 pi FL, and XC is equal to, that is 1 by omega C. So XC is equal to, that is 1 divided by 2 pi, that is 2 pi FC. 2 pi FC. So this is XC. Here F means frequency, L means inductance, C means capacitance. If I know these values, I am going to find impedance in this circuit. General formula, that is, and Z is equal to, that is V divided by I. So remember children this one. So now here cases will come. So if XL is equal to XC, XL is equal to XC, means inductive reactance is equal to capacitive reactance. Then what happens here, this form will take that Z is equal to square root of R square. It becomes square root and square cancelled. It has become what children? So this is called purely resistor. So this is nothing but it is equivalent to the voltage passes through the resistor when this inductive reactance is equal to capacitor reactance. So now here phase difference is equal to 0 degree. Remember this first case. Second case, if XL is greater than XC, this is the inductive reactance is greater than capacitor reactance, then it is going to become, so before that we should remember one more formula, phase angle, that is tan pi is equal to, that is VL minus VC divided by VR. This is voltage in the inductance, voltage in the capacitance, voltage in the resistor. Now here by using this, then pi becomes it positive. XL is greater than, that is XC. We can write this is XL XC divided by XR. Then it becomes tan pi is equal to positive. Then it is called dominated by, that is inductance, dominating by inductance circuit. And here voltage lead by, that is certain angle pi, that is equal to 90 degree. Similarly, third case, if XC is lesser than XL, this is less means this tan pi becomes negative, then this is called capacitive reactance, means the circuit is dominating by capacitive reactance. So these are the phases, these are the special cases that we can find in when AC voltage passes through LCR circuit. AC voltage passes through LCR circuit. Please note down. So after understanding this, let us go for, that is Q factor. So what is Q factor? Let us understand very fast. Dear students, before that we should know the terms resonant circuit. So after passing this voltage, we have provided potential difference. After providing potential difference, what happens? At particular frequency, so if I take a graph frequency, then what happens here? At particular frequency, current which becomes maximum, So that is called resonant frequency. the frequency of AC at which current becomes maximum in the circuit. That is called I naught, means as I told you, peak current. Peak current. So this is called resonant circuit. In the resonant circuit, remember that is condition for resonant circuit is Xc is equal to XL. That is inductive reactance is equal to capacitive reactance, or capacitive reactance is equal to inductive reactance. So here XL means we know 2 pi FL directly, and XL means this is 1 minute children, that is XL, this is Xc is equal to XL, and you can take XL is equal to Xc. Inductive reactance is equal to capacitive reactance. So directly you can take, that is 2 pi FL directly. This is nothing but omega C. Omega means what? 2 pi F. It becomes, that is 2 pi FL is equal to this 2 pi FC. Now I want to find what children? Frequency. So then cross multiply, you will get F square is equal to 1 over 4 pi square. This 2 into 2, 4, pi into pi square, and again L into C. So F is equal to what happens children? The square root of this comes, then 1 over 2 pi square root of LC. So this is the formula for very important, which is used in the CET and NEET exam, that is resonant frequency is equal to FR is equal to 1 over 2 pi square root of LC. Please note down. So after understanding this, here we will find again, suppose that is peak current, RMS current. So this is RMS current, that is, you know that I naught by root 2. So here we are going to find again two frequencies. How many frequencies? Two frequencies. So then the difference between this F1 and F2 correspond to, that is RMS current, that is called bandwidth. That is, so bandwidth is equal to difference in frequencies. Okay, bandwidth is equal to difference in frequencies which correspond to RMS current, that is I naught by root 2. Now we are going to define one more definition, quality factor. So what is quality factor children? Very simple, the ratio of resonance frequency divided by bandwidth, that is FR divided by F2 minus F1, or you can write that is omega naught L divided by R, or you can write omega naught C divided by R. This is all about quality factor, and this is resonance frequency. Please note down. Very useful formula for CET and NEET exams. So after understanding this, let us go for LC oscillations. So what is LC oscillations? So here we are going to find inductor and capacitors. So let us consider a capacitor. This is the capacitor and connected to inductor. So now plus, you know that capacitor which is going to store the electrical energy. Okay, it is going to store the electrical energy. Now here this capacitor going to be discharged to the inductor. So then what happens here? Then we are going to find here electrical oscillations, and this electrical oscillation is nothing but, that is LC oscillations. LC oscillations means when the capacitor is charged and discharged to the inductor, then we can find in this system there is an electrical vibration, electric field vibrations, and these vibrations nothing but LC oscillations, and it's given by frequency, that is same F is equal to 2 pi square root of LC, same thing like resonant frequency. Now here the energy produced here, this is on account of magnetic energy, and this is due to presence of electric energy. So the total energy in the system formula is very important. I am not going to explain in detail, just formula remember. That is total energy is equal to the energy of capacitor plus energy of inductors. We know that energy of capacitor, that is energy stored in the capacitor, of CV square, and this is of Li square. C means capacitance, V means voltage, here inductance, current. So this is due to magnetic energy and this is due to electrical energy. This is all about LC oscillations. So after understanding this, let us go for next term, transformer. So dear students, what is transformer? So you might be heard that in your areas sound will be producing. So what is transformer? It is the device either to increase or decrease voltage. Okay, so this is a symbol for transformer. So we have quoted on the soft iron core, that is copper wire. P is called primary coil, S is called secondary coil. Dear students, what is primary coil? This is first coil. This is called secondary coil. So what is the meaning of transformer? The device used to increase voltage or decrease voltage, that is called transformer. So after understanding the definition of transformer, there are two types we can find. Step up transformer, step down transformer. Step up means what? Very simple. Step up. So transformer. So what is step up transformer? Very simple. Let us understand, very simple. The transformer which increases the voltage. Transformer which increases the voltage and decreases the current. Very important. So here in the form of flux leakage, I'll explain that factors. So we are going to increase the voltage and decrease the current. And here remember, the current in the primary coil is greater than secondary coil, because here increased current and again we have decreased in the secondary coil. So IP is greater than, current in the primary coil is greater than current in the secondary coil. This is step up transformer. Step down transformer. Reverse. Step down transformer. So here we are going to decrease the voltage. Step up means what? We are going to increase the voltage from substation to main station. Voltage will be increased. Again, your transformer to your home, that is step down transformer. Voltage is going to be decreased. Here, substation to main station, voltage is going to be increased. Now here, what happens here? Which decreases the voltage and increases current. Very, very important. And here current in the secondary coil is more than primary coil. So now my point is that here there are some losses, very important for CET children. I'll explain like a piece of cake. Let you listen one by one. Okay, the first point is that copper loss. So loss, okay, so what is copper loss? When I pass current through this primary coil and secondary coil, so it has some resistance. So where there is a resistance, there will be opposing force. So opposing force means it produces heat. So here this electrical energy is dissipating in the form of heat. It is wasting in the form of heat. So that is called on account of copper loss. Second one will come, that is flux leakage. So what is flux leakage? So consider here primary coil, secondary coil, there is no perfect coupling, and thence when there is no perfect coupling, the electrical energy, it is going to be dissipated in the form of heat and energy. Okay, so then when I join this primary coil and secondary coil 1 over, we can avoid this flux leakage. And how can we avoid this copper loss? We have to use thick wires. You know that thickness will increase means it contains more number of electrons. Then we can't find resistance there. So this copper loss can be reduced by increasing thickness of the wire, and this flux leakage can be reduced, that is coupling. There is a perfect coupling between primary coil and secondary coil. Third one, that is eddy current loss. Okay, or you can call hysteresis loss. Hysteresis loss. So what is eddy current? In the core of the transformer, there is going to produce large amount of heat and energy. So it is going to lose the energy. It is going to lose the energy. So that is loss in the form of heat and energy. Again, hysteresis. So sometimes we are going to be magnetized and demagnetized. So this circle will take place often. So magnetization, demagnetization. So there is a loss in the form of heat and energy. That is hysteresis loss. So last one, that is loss due to vibrations. Loss due to vibrations. So you might be seen that beside the transformer, we are going to produce a sound. Zzz. This sound, why is it coming? Why this sound has come? That is, when it is converting voltage, that is lower voltage into higher voltage, there will be vibrations. That vibrations, that is electrical energy, will convert into mechanical energy. So according to law of conservation of energy, it is converting electrical into sound energy. Mechanical, electrical into mechanical, mechanical into sound energy. So there is a dissipation, there is a loss in the energy. So due to this reason, there is a loss due to vibrations. So after understanding this, very important for CT, that is formulas will come. Let us understand within 2 minutes. So turns ratio, that is turns ratio, very important. So 100% is fixed. Based on this, you can go through any question papers. Very important for CT and NEET. So now here, turns ratio means, we know that here we are going to find a very important principle. Already we discussed mutual induction. So what is mutual induction? The process of producing EMF in one coil and change of current in another coil. That is called mutual induction. So what is my point here? The EMF is going to produce in the primary coil as well as secondary coil. So according to second law of Faraday's laws of electromagnetic induction, we know that is ES is equal to minus, that is NS dou pi by dou t. Similarly, the EMF in the primary coil, that is minus NP dou pi divided by dou t. So if I take ratio, that is ES by EP is equal to NS by NP, because dou pi by dou t cancel each other, minus by minus it becomes plus. This is called turns ratio. Turns ratio of the transformer. Very important, they'll ask in the exam. Turns ratio of the transformer. So again we'll get one more expression, that is relationship between current and voltage. That is IS into Vs is equal to IP into Vp. These two formulas are very important in CET. IS into Vs is equal to IP into Vp. Now here, if it is perfectly ideal transformer, then what happens here? That is NS by NP is equal to Vs by Vp. So the EMF is changed into voltage. Voltage in the secondary coil by voltage in the primary coil is equal to, this is called perfect transformer, we can call ideal transformer. And last but not least, that is efficiency is equal to output by input. And they may ask you efficiency percentage in the CET and NEET exams. So here output means what? That is, imagine that is IS into Vs. Input means IP into Vs into 100. So this is all about alternating current. I hope you understood, students. If you understand, please like it and subscribe, and please press that is bell icon. Thank you.